Hi, today we are working on the HiSet Practice Test, FPT7. This is the latest released test for students. And I'm going to look at questions 5 and 7 together, and then we'll go to question number 6. The reason I'm doing 5 and 7 together is not just because they're on the screen the way that they're on the screen, but because they use the exact same method to solve the problem. Okay, so I want to show you how these two different problems are using the exact same method. First thing I want to do is let me go to my whiteboard so that you can see what I have set up here. Okay, so what I have is I have a restaurant that is at 75% capacity with 120 patrons. All right, that's important for your students to either write down on their scratch paper or, find some way of highlighting it, underline it very lightly in pencil or whatever they need to do, because those two numbers are important. They belong together. So 75% capacity with 120 patrons. How many people, we do not know, are in the restaurant when it's at 100% capacity? So what we have to look at is the fact that we have patrons, which are people, and we have an unknown, okay? And then we have these 2% that are together here. So each part of this problem has a percent and a number that refers to people, okay? So what we're going to do with this is we're going to set up an equation that's going to help us solve this problem and help us figure out exactly what's going on, okay? So the best way to do this is to take your 75, we have 75% gives us 120 patrons, okay? And that is the same thing as 100%, or it's equal to 100%, giving us an unknown number of patrons. So what we have here is an equation that we've set up. The percent is on top, the number of people is on bottom. And now all we have to do is we have to solve for x, okay? Now the way that this is going to work is going to be a little bit strange to a lot of people, but what we're going to do with this is we're going to solve it as if, we're solving for x, so we're going to have to move some things around, okay? Whenever you're moving things around, let me clear my board. Whenever you're moving things around, we have a 75 over a 120, and we have a 100 over an x, okay? When you're moving things around, you want to get the x on one side by itself. I always tell students they want to get their x by themselves. They want their x to be alone, so we want the x on one side. So the first thing that we're going to do is we're going to multiply both sides by x, okay? That makes students very uncomfortable. I'm not sure why, but it does. What ends up happening with this when we multiply each side by x is we have this x will cancel out, as will this one, and it will leave us with the 100 on this side, okay? And on the other side, we're going to have a 75x over 120, okay? Again, we're trying to solve for x. We have a regular number here, we have a fraction over here. So we're going to have to do some multiplying again because we've got to get rid of that 120. So what I'm going to do now is I'm going to multiply each side by the 120. 120, okay? And when I do that, what happens here is that this 120 and this 120 will cancel out, and they will give us 75x, okay? Equals, now I don't want the students to take a chance of messing up on their math here because there are a lot of zeros in this next number. So I want them to go to the calculator and type in 100 multiplied by 120 and tell them to be sure that they get the correct number of zeros. Otherwise, it's going to mess up their entire answer. So what we have is 12,000. So there would be 3 zeros there. 1, 2, 3. We're almost done. Now what we need to do is we need to get rid of the 75. So now we're going to divide each side by 75. Divide by 75. And when we do that, these two 75s will cancel out and give us an x. And back to the calculator. 12,000 divided by 75 will give us 160, which is going to be the answer. Okay? 160. There is another way to solve the problem, but I want them to get used to doing things in this particular way, because if they do it the other way, it may be a little bit confusing to them, especially when they start considering the fact that this particular setup is what you need to use to solve problems like this one. Okay? So what we have in the second problem is Ms. Lund placed a 7-foot ladder against a wall with the base of the ladder 4 feet away from the wall. Then she decided that a different ladder, which was a 10-foot ladder, needed to be used instead. She wants it to rest against the wall at the same angle as the shorter ladder. So that means if the short ladder is at an angle like this, she wants the long ladder to be at that same angle. Okay? So what we're trying to figure out is how far away from the wall should she place the base. This is the exact same type of question because what it has is it has two sets of information. One set we know and one set we don't know. Okay? So what we have with this one is we have a 7-foot ladder that is 4 feet away. And what we want to happen is we want there to be some sort of equality there with the 10-foot ladder that would be placed at some unknown distance. Okay? So this is the way this particular formula would be set up. You would have the ladder and the feet, then you would have the ladder and the feet away, the base away. Okay, so this is the length of the ladder, this is the base, this is the base. So let's take this to the other whiteboard and see what we can do. Let me clear the board. We had a 7/4 equal to a 10/x. We're going to use the exact same method that we used a minute ago. We're going to first of all multiply both sides by x. And when we do that, these two x's will cancel out and will give us a 10 on this side. What happens on the other side is we have a 7x/4. Now what we're going to do is we're going to multiply both sides by 4. Okay, these two 4's will cancel out and give us a 7x on this side, and this will give us a 40. Now we need to divide each side by 7 so that we end up with an x on this side and some number on the other side. Again, calculator. This is where the students need to be using the calculator. We're going to take the 40, we're going to divide it by 7, and our answer is going to be 5.714287. They're not going to use that whole thing, okay? So the answer that's going to be used on the test is going to be 5.7 feet. They're not going to use the whole big long number that is used right here. Students need to understand also I forgot what the number was, 5.7. Students need to understand also that if they have a number like 5.76, that what would happen here is that this 6 would cause us to have to increase this 7, so that the answer here would be a 5.8. A lot of times students don't fully understand how to round up or to round down. So when they see an answer like what we just got, they say, but my answer was 5.71. So what am I supposed to do with that? They don't understand that a 5.71 actually rounds down to just a 5.7. So be sure that you are explaining to them exactly how rounding works. Otherwise, when they see problems like these, it's going to be extremely confusing to them, and it's going to be much harder for them to figure out. Okay? Now, what I want to look at really quickly. Oops, I went too far. No, I didn't. It's right there. Okay. I want to do this next problem, and I lost my timer. Let me go back to my online stopwatch. I'm just going to use this one real quick. Okay? I'm going to get it started, and then we're going to go back and look at the next problem. Okay. It says several students are going to ride their bikes from the city park to Lake Kigonsa, a distance of 25 miles. They'll ride at an average rate of 10 miles an hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? Students should be able to look at this automatically and know if you're going 10 miles an hour and you're traveling a distance of 25 miles, it's going to take you 2.5 hours to get there. They should not have to think about this at all. 10 miles an hour and 25 miles gives you 2.5 hours is how long it's going to take. Okay? So, keeping that in mind, if we have 2.5 hours, 2.5 hours, and our end time needs to be 11 o'clock, what we have to do, it says they'll ride an average rate of 10 miles an hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? We need to take 11 a.m. and subtract 2.5 hours from it. Now, students have a really hard time with time, and I'm not really sure why. A lot of times students think that if you're talking about a quarter of an hour, like if I were talking about 1:15 and I said a quarter of an hour, a lot of times students think that means 25 minutes, not 15 minutes. So here's what I'm going to do. Make sure your students understand time. I'm going to subtract 30 minutes from this because that's what a half an hour is, and that's going to leave me with 10:30, because if I subtract 30 minutes from 11, that gives me 10:30. Now I'm going to take 2 hours away, and that's going to leave me with 8:30. Okay? So the students need to leave by 8:30 in order to get there on time. That particular problem took me 2 minutes and 31 seconds going the long way around with it. So